here I'm going to introduce the concept of stoichiometry, which is essentially just moles in chemical reactions. So when we have a chemical reaction, we start with these chemicals that haven't collided yet, and we call them reactants. Now those reactants, when we add them together, sometimes what's going to happen is they'll collide with each other because they're all moving, and when they collide with each other with enough energy, they sometimes form products. For more on that energy, see the activation energy in the rates of reaction section on the website. But for now, we know that the chemicals we start with are called reactants, and they turn into products. Stoichiometry is all about the quantities in which they react. So I'm going to start by talking about a fairly common chemical reaction, something that happens in the lab all the time. So when you light a Bunsen burner, you're essentially taking natural gas, or methane, which is our reactant, and that chemical formula for methane is CH4. And let's say we react it with oxygen in the air, and the products that are always formed when you chemically react methane with oxygen, with enough oxygen in a combustion reaction, are carbon dioxide, CO2, and water. So effectively what's happening there, all the carbon reacts with the oxygen to form carbon dioxide, and all the hydrogen reacts with oxygen to form water. Now I'm just going to balance this because it's not balanced, so you can look back at the balancing equation video to get more of an idea of what to do. So when we're balancing combustion reactions, we just start with the carbons. Now here I've got one carbon there, and I've got one carbon there, so they're balanced. I've got 4 hydrogens on the left in the reactants. I've only got 2 in the product so far, so what I'm going to do is I'm just going to put a large 2 in front of that water to say that there's 2 water molecules, but now I've got 4 hydrogens on the right, and I've got 4 hydrogens on the left. So the last thing to balance is our oxygens. I've got 2 oxygens on the left, but on the right I've got 2 times 1, which is 2 oxygens, plus the 2 oxygens from carbon dioxide. So there's 4 oxygens in total on the right hand side. So what I need to do is double up this oxygen molecule on the left. So I have 2. Now that is a balanced equation because I've got the same number of atoms on the left as I do on the right. And that's, the law of conservation of mass. If we start out with a certain number of atoms in our products, we will end up with the same number of atoms, but in a chemical reaction, they're just going to be rearranged. So what I have here is 1 methane molecule reacting with 2 oxygen molecules to give me 1 carbon dioxide molecule and 2 water molecules. So I'm just going to draw them out just to start with, just to help with the process of stoichiometry. So I've got 1 carbon surrounded by 4 hydrogens. I've got 2 oxygens. I'm just drawing the atoms in certain colours. Okay, so I've drawn them out there in full. What this means is, because I've got the same number of atoms on both sides of the reaction, what happens is, when carbon burns an oxygen, that carbon atom, let's just say I had one of the carbon atoms, that carbon atom reacts with the oxygen to form carbon dioxide. The carbon has 4 bonds to start with, and there's 4 bonds in the products. So 1 carbon atom makes 1 carbon atom. Now, the 4 hydrogens of methane also need to react, and it just so happens that in this chemical reaction they react to form water molecules because the hydrogens themselves also get attached or bonded to oxygen atoms. So as I've got 4 hydrogen atoms there, I need to make 2 of the water molecules because the chemical formula for water is H2O. So I can't have H4O because that molecule doesn't exist. So I've got H2O, and because I've 4 hydrogens at the start here, I need to have 4 hydrogens at the end. There. Now, because I've created 4 oxygen atoms in my products, they had to come from somewhere. So they came from the 4 oxygens in 2 molecules. Okay? So while we balance the equation to get the same number of atoms on either side, it tells us the proportions in which everything has to react in the chemical reaction. So let's just say this water was extremely valuable and I really, really needed this water. I would create 2 waters only if I had 1 methane and 2 oxygen molecules. I wouldn't create my 2 waters in any other way. I would need to have that. So this is what stoichiometry is. It tells us how they react. So 1 methane reacts with 2 oxygens to give me 1 carbon dioxide and 2 water molecules. That is just the proportions in which they react. So let's just now say I didn't start with 1 methane molecule. You'll never start with 1 methane molecule because obviously if I had a drop of that, I would have billions and billions of methane molecules. So I won't ever start with 1 methane molecule. Let's say I started with 2. Again, hypothetical. If I started with 2 methane molecules, well then I would need to have double the amount of oxygen. So I'd need to have 4 oxygens, and they would always produce 2 carbon dioxides, and then it would always produce 4 water molecules. Okay, so the balanced equation tells us the ratio in which the molecules react. Now, because atoms and molecules are so small, we have a tendency not to group them by just individual molecules, but by moles of molecule. And there is a video on moles, okay, on the website. 1 mole of any substance is 6.02 by 10 to the power of 23 particles of that substance. So if I had 1 mole of methane, I'd actually have 6 by 10 to the power of 23 molecules of methane, which is a huge number. Okay, it's 6 with 21 zeros after it. Okay, that would be the number of particles. So let's just now say I had 1 mole of methane, and this is called the mole ratio. I'm just going to get rid of what I have here. 1 mole of methane will always need 2 moles of oxygen. It will always produce 1 mole of carbon dioxide and 2 moles of water molecules. That's just how they react. Okay, if you want to form those products, they have to react in that way. Okay, and that's called the mole ratio, which is essentially just stoichiometry. So now I'm going to go through a practice question on this. I'm just going to reduce the size of some of the stuff here and talk about it, because we don't always just deal with number of moles at the start. Okay, so let's try and answer a question on this. I'm going to say I had, to start with, 24 grams of methane. So I have a canister and I've got 24 grams of methane. Now, usually using gases, we're going to be using volumes of gases, but let's just say for now we're dealing with the number of grams. Okay, so I've got 24 grams of methane. The question asks, what mass of water will be produced in the reaction? Here we're going to be using stoichiometry to give us our answer. Now, in terms of the mass of a substance, the mass of a substance only tells us so much in chemistry. When you want to predict the amount of a substance, we deal with the number of moles of a substance, okay? And from that, we can gather the number of molecules of that substance, or particles of that substance. So, if I have 24 grams of methane, the first step here is to work out the number of moles of methane. And I'm just going to stick with MOL for mole. Mole of methane. We use our formula, moles equals mass over the MR. So the MR is the relative molecular mass of the compound. So I have the mass of methane is 24. So for more on that, have a look at the website. So 24 grams. And the MR of methane is going to be 12 for carbon plus 4 hydrogens, which are 1 each. So we're going to say it's 16. So the number of moles of methane is 24 divided by 16, which is 1.5 mole. That seems like a small amount of methane, but 1.5 moles of methane is going to be 1.5 times 6 by 10 to the 23 molecules of methane. Okay, so you're talking about 9 by 10 to the power 23 molecules of methane. So a huge number of molecules of methane there. So that's what I'm starting with here. Okay, I'm starting with 1.5 moles of methane. Okay, the next step is to use our mole ratio. Okay, now I know that when I looked at it down here, 1 mole of methane reacted with 2 moles of oxygen to give me 1 mole of carbon dioxide and 2 moles of water. So I'm here just comparing methane to water, because the questions ask me what's the mass of water formed. So in terms of this then, for the mole ratio, I'm comparing methane to water, which is H2O. Well, if I had 1 molecule of methane, or 1 mole, I know that that gives me 2 moles of water from my balanced equation, because 1 mole of methane gives me 2 moles of water from the balanced equation. So the problem here is I don't have 1 mole of methane, I've got 1.5 moles in the question. So 1.5 moles of methane, if the ratio is 1 to 2, for every 1 methane I have double the amount of water. For every 1.5 methane I'm going to have double that, which is 1.5 times 2, which is obviously 3 moles of water. So I know that if I start with 24 grams of methane, I end up with 3 moles of water. Well, the question asks what mass of water is formed, so I go back to my moles in chemical reactions, and mass is equal to mole times mR. So therefore mass of water equals 3, which is the number of moles, times the mR for water. Well, the mR for water, there's 2 hydrogens and there's 1 oxygen. The oxygen atomic mass is 16, rounded, and hydrogen is 1, so there's 2 of those. So it's going to be 18. So the mass of water is going to be 3 times 18, which is 56 grams of water. And that's essentially what stoichiometry is. It's using balanced equations to work out the proportions at which things react. Okay, I've gone through it in first principles, which is what I'd always advise people to do. If you start with a certain mass or volume of a substance, number 1 step, work out the number of moles of that substance. Always the second step will be to see the proportions in which they react. So use the balanced equation, just the numbers in front of them, provided you balanced it correctly, to work out the number of moles of product or reactant formed from either the product or reactant. Okay, depends on the information you're given in the question. When you know the number of moles from the mole ratio, all you need to do there is use your standard moles formula to work out the mass or the volume, depending on what they're asked in the question. That is just a basic introduction to stoichiometry.